Of Sophia. So I work on a team called the platform team. It's headed up by Jessica Berliner. I'm an architect on the team. The other architect some of you may have talked to or interacted with is Alex Mulholland. Her and I kind of share the architect duties on this project. And as we'll talk about, Sophie and our Solution Factory is really trying to become the HCL cloud native face for the portfolio. So, you know, we've got the existing portfolio. Pieces of it are trying to become more cloud native over time. Users these days, especially ones that know anything about Kubernetes or anything about that space, expect companies like us to have a easy to browse catalog of services and products they can choose, have those things be easily deployable into Kubernetes, and so on. And so this is what Sophie is trying to be. We're just in beta at the moment, so we haven't shipped anything yet, but that'll be later this year. And so that's the product I work on. I'm based in Toronto, and most of our team is actually based in Cary, North Carolina. Okay, so let's dive in here. So let's start with, why is cloud native a strategy point for HCL? So we're going to get to that, but before we do, let's talk about what do we mean by the term cloud native. So when you go out and search for the word cloud native, you'll find lots and lots of different definitions, lots of blog entries or articles on the topic, and they're all kind of different. So you kind of have to pick your reference sources a little carefully. There's a open source open consortium called the Cloud Native Computing Foundation, and they're as good a source as any. So they are trying to foster a community that drives cloud native best practices, as well as kind of vendor neutral tool choices, and primarily focusing on open source. So they really want to drive adoption of cloud native technologies. And the best way to do that is to have most of the tools be free and have them be stable and robust and supported by big companies and so on. And so that's what the Cloud Native Computing Foundation is all about. And you can go to their website and browse around. They've got a tremendous amount of material there. And actually we'll cover it a little bit in this section. But when you look at how they describe cloud native, this is their definition here. This is just taken directly from their site. And you'll notice they don't actually talk about any tool choices here. In fact, you know, the word Docker is not mentioned, Kubernetes isn't mentioned, other open source tools aren't mentioned here. What they're talking about here are the best practices and the outcomes that companies are starting to realize when they move towards a cloud native approach. So really it's about building applications in a certain way. So some of it is about application architecture choices, things like using containers or using these things called service meshes, which maybe we'll talk about, but it's kind of an advanced topic. We might not get there, but I'm sure most people have heard about microservices and good APIs. And so it's primarily about that from an application building point of view, but really it's about how do these cloud native applications take advantage of what is called cloud native infrastructure, meaning orchestrated container management platforms. Kubernetes has basically won the container orchestration platform battle. A couple of years ago, there actually was a battle. There's Docker Swarm and some other choices, but Kubernetes has really won that battle. So that they could actually say Kubernetes here, but they don't. But basically, it's how do your applications take advantage of what Kubernetes has to offer, and that is by building your application in a way that it can be resilient. It's got good observability. You can do proper CI/CD and DevOps and deploy frequently and so on, and scale and all the good stuff that you see kind of the best of breed applications out there in the world doing today. Kind of unlimited scale and so on. So, but that's just their definition. And so we need to internalize this in HCL and come up with our own sort of positioning here, because as we'll see, it's a really broad landscape of cloud native concepts and technologies. So we're trying to simplify this both for our own purposes so that we can help advance our portfolio, which obviously is big and getting bigger every day. We need to find a way to simplify these messages down, both for our own development teams, but also for our clients, because we don't want to come at them with a message of, oh, cloud native's hard and there's 1,000 things you have to do before you're good at it. You really want to start with the basics and you want to build up from there. And it's actually quite easy to show some success. And we'll talk about that in the context of Sophie a bit later and some of the work we've been doing with the product teams. But for us, when you kind of search across all the definitions, it really comes down to a couple things here. From a technology point of view, it's microservices, containers, and some orchestration platform. And as I mentioned, that's Kubernetes. But from a best practice point of view, it really does mean, in some cases, a culture shift, if not a process and tool overhaul for development teams. You want to start adopting more open technologies, and especially integrating into open technologies. As we'll see later, there's some logging and monitoring tools in Kubernetes that are extremely popular, Prometheus and Grafana, for example. And if you don't integrate with those, you're going to be left behind. So there's a part of this that it almost impels you to understand the open landscape and plan your integrations accordingly. But it's also about automation, real DevOps, real CI/CD, and so on. So if we take this if we step back a bit about why we're doing this now, I think the real impetus for Sophie or Solution Factory, it's been in the works now for 2 years or so. And when Darren first started this project and kind of tasked Jessica with kind of building a team to do it, I believe the business problem was, he had been on a buying spree, and we built up this huge portfolio of products, and almost all of them have completely different install experiences, licensing experiences, usage, day-to-day experiences, and so on. And so he was trying to get to the point of how can we extract kind of some value or some services out of this portfolio and expose it in new and modern ways. So the initial kickoff of Sophie was, let's talk about pulling out some key capabilities from the products and building microservices. And as we'll see, it's grown from there. Now we have full products in Sophie. But it's kind of a strategic thing as well. It's not just about modernizing our portfolio. When you go out and look at where the market's going, you see lots and lots of activity here, and customers and clients are at all ends of the spectrum here. Some are just getting started, some are pretty far advanced, as I mentioned earlier. But one thing I'll just point out, the bottom left column here, or bottom right, sorry. When do you expect your organization will adopt a cloud native infrastructure? And by that question, they mean, when will you have your infrastructure fully support Kubernetes or orchestrated containers running as a primary production environment or development environment? And the answer, basically the majority of the answers come back at 3 years or less. Most people are saying it's 2 years, and this was from a survey from last year, basically a year ago. So it's pretty clear the market's moving here, and this is just one example. You can find many examples of Kubernetes adoption. But if we don't do something here, we are going to get left in the dust by our competitors. Is the key takeaway here. So I'm not going to go through this chart. It's a bit of an eye chart, but it's us trying to say, given our current portfolio and our customer experience with our portfolio, what benefits can we hope to derive, or can we measure ourselves against as we start to move parts of our portfolio to become more cloud native? So, most of the things on the left here are things that our customers struggle with today and kind of where they'd like to be. So rather than have our products have a specific set of system requirements where they can only run on version X of this operating system, really, eventually, you want our offerings to run on generic cloud resources wherever possible. And in this case, this means Kubernetes and the cloud native space. So this means having our software be runnable on day one in generic Kubernetes infrastructure. Being able to easily combine and discover and try out all of our capabilities. Again, this gets back to the catalog, which we'll see in Sophie in a minute. And yeah, basically they want capabilities from the HCL software portfolio that match or mimic the capabilities they're getting from other vendors in their catalogs. And so, you know, we need to understand how this market is evolving. And as I said, most big players in the cloud native space have some sort of catalog of applications. If you go to, for example, Google or AWS or Azure, you're going to find a catalog of applications that with a few clicks you can go install into their infrastructure and be up and running in, you know, a matter of minutes usually. And so that's the install and usage experience that we're up against and trying to emulate. So yeah, I'm not going to go through this whole list because, but it's a thing we spent some time on. Back on the Cloud Native Computing Foundation. So one thing they realized very early on is that people were struggling to understand what it meant to actually get on the road towards cloud native for their own applications or their own environments. And so what they've done is they maintain this thing called the trail map, sort of a graphical representation of 10 things that you could be focused on if you want to start to move towards cloud native. And they're not saying in this chart that you need to focus on all 10. It's more of a strategic view of here's 10 things you could be focusing on. But the first one is always the first one. Containerization is sort of table stakes for all of this. Oh, there was a question about the link. I have the link right here. I'll paste it in while we're talking so you guys can take a look. And this link I think is old actually. Actually, if you go to if you want to follow along with me, if you go to the cncf.io, let's all go there together. You go to CICF, you go to projects, and there's a cloud native trail map link, which should take you to what I'm showing here. So this trail map is supposed to, as I said, provide a kind of a bunch of milestones or goals that you could be thinking about. Containerization, as I said, is always step one. And as we'll talk about when we talk about the HCL portfolio and how we're trying to modernize it, it really is step one. You focus on containerizing something, and then you can focus in on some of the other aspects. And so you can see some of the items here, CI/CD. So this is really about making sure you're set up to do proper delivery and actually taking advantage of the fact that, you know, once you've built a container once and you've got that into your DevOps pipeline, it actually makes CI/CD so much easier. As we'll see when we get to the bit on Docker images, just the act of containerizing something makes it that reusable asset that can flow throughout your DevOps pipeline and provide really reusable, robust capability in any environment because you know it's a packaged version of something that contains all the dependencies it needs and it's going to run anywhere the Docker can run. Orchestration, this is basically Kubernetes. In fact, they say it here, Kubernetes is the market leader. Observability analysis, this is one of the key aspects of cloud native applications, is the ability to say, it's not just about deploying an application, it's about how do I manage it day to day. And so today with our legacy applications, each of them has their own logging capability. Some of them, you know, will do syslog, or some of them will do some log aggregation or other things. There are technology approaches in cloud native where people are plugging into existing logging frameworks. And as I said earlier, the expectation from customers is it's gonna be not that we come with our own logging capability that they've got to learn and figure out and integrate into their own day-to-day system reliability engineer process. It's going to be more about how do we integrate into what they've already got. And usually that's based on some of the common tools in Cloud Native for monitoring and logging. There's some other things here, service mesh. We'll talk about that a bit. That's more of an emerging topic, which is basically a cluster level thing you install to control and monitor more closely how your services inside your cluster are talking to each other. The other ones are, networking, database, messaging. For us, these last two here are really important. So the container runtime, this is about what Kubernetes is using to run your containers or how your cluster's set up. But software distribution, this is the big one for HCL. How do we actually deploy containerized versions of HCL software to end users? We have some products today that have been containerized for years, like Urban Code Velocity and others. The way they ship to customers is quite suboptimal because we don't have a better solution in HCL. The way they ship is they ship a very large tarball in FlexNet, which contains all of their Docker images and Helm charts, which we'll talk about later. But the customer experience is, I need to download this big tarball. I need to run some commands to extract those images into my local Docker engine that's running on my local machine. Then I need to push those images to whatever Docker registry we have internally, and then I can think about deploying Urban Code Velocity. It's not an experience that is friendly to those that are in this space. Customers who are doing Kubernetes and Docker expect there to be registries that they can point to that have all the images they need and get pulled down dynamically as needed when things get deployed into their Kubernetes environment. So for us, this is a big thing we're trying to help solve with the SOFI project, is how do we do cloud native software distribution in HCL? We've got some answers, but we also have some gaps that we're still trying to solve. And we can talk about that if there's time. Okay, so one thing that we've also done, and this was done at the level of the product management team, is we're trying to measure where we currently are in our portfolio. And again, we wanted to keep this measurement activity as simple as possible. Obviously, we're not going to measure ourselves on those 10 things that we just saw on the trail map. That would be far too much, far too granular. For our purposes, we can measure things much more simply. In fact, we boiled it down to these 3 things: containerization, orchestration, and cloud native maturity. So basically what this means is the product containerized, or do you have a service in your product that you can containerize? If so, you get a check mark for that. Once you've got and actually we'll see this in the Docker hands-on section. Once you've got your stuff containerized, the next question is, can you run in Kubernetes? And just getting your container running in Kubernetes is good enough really to get a check mark. If you can run there, that's great. People can stand up your product probably much more simply than they can today because they can run a few commands and get your product stood up inside a cluster. The last piece here, cloud native maturity, this is where I don't think we really have many products in this space now. Maybe Urban Code Velocity would be here, but this is about applications fully taking advantage of what's available both in Kubernetes and in the industry-leading tools like the logging and monitoring and other things. So basically, this last piece here is kind of the nirvana, where a customer that's mature, for example, on Kubernetes would take one of our offerings and it would just fit seamlessly into what they have, and they would be perfectly happy with the experience. So that's really what this last thing is about. It's about, we've containerized, we can run in Kubernetes, but now we're taking advantage of all the goodies it has to offer. So we actually came up with a little maturity model here based on those levels. So level 0 means we haven't done anything for a given product. We haven't containerized. We haven't even looked at this yet. And we try to come up with an action plan to help product teams get to the next level. I think most people on this call are from DX. So obviously DX is containerized now and runs in OpenShift. So, it's pretty far down this list. That is definitely level 2. And then to get to the next level, I think we We need to understand how to install it into generic Kubernetes infrastructure and take advantage of all the stuff that's there. Okay, so the next section, I'm just going to talk a bit about Docker. For those of you that have played with Docker, this will be complete review, but I'll go through this as quickly as I can, but not try to skip over it too much, because it really is the foundational technology for everything we're doing here. So understanding what Docker images and containers are is very important. So a few things we like to stress for folks that are just getting started is understanding upfront what's the difference between a container and a virtual machine. It's actually one of the first things I had to wrap my head around a couple of years ago when first getting into this space. We'll talk a bit about the architecture, but not too much, one slide. And then the key terminology that you need to know if you're going to do anything with containers specifically. And then I'll show you some stuff in action. As I said, this won't be a hands-on part, but I'll show you how to install the Docker desktop tools, and you can try all this yourself if you want. It's actually really, really useful, especially for development teams, but also if you want to manage your own demo environments locally or something, you can containerize things and manage them that way. Okay, so what is the difference between a container and a virtual machine? The answer is really about where the abstraction layer lives. So with VMs on the right here, it's really the physical hardware that's being abstracted away so that you get full copies of an OS and everything on top of it running on the same host. And so I'm sure everyone on this call is very familiar with VMs, so you know how those work. The difference with containers is the abstraction layer is actually a level higher. Containers are not full operating systems. They are, the abstraction layer is basically the application level. And so containers actually share host resources. They share networking, they share storage, they share users, other things, but they have their own isolated view of all of those things, their own namespaced view. So container A thinks, so when it's running, when you have a process running in container A, it thinks it's the only thing on the system. If it does system calls to say, give me all the users or show me all the processes running, it only sees itself. It only sees stuff that is inside its own container. Same thing with container B and container C. And so it's a level of isolation and it's a level of sharing on the same host that's much different from VMs. And the important thing to note here is this means because there's not a full copy of the operating system in every container, they're much smaller and they start much more quickly. So the best mental model to have about what a container is, it's not an operating system running lots and lots of stuff. A container is really a process running on a host. So typically a container will just run one main process, and when it's done, it'll exit. Or if you're running a server, it'll run a long-running process. But that's it. Its job in life is to run a process. But to do that, it can have its own view. It looks like it's running on a full operating system, but it's really not. So that's the difference, and we'll see this in action a bit in a second. The Docker architecture, I only show this because if you start to work with Docker, you might wonder about some of these terms. So starting on the left, the Docker client, so typically all of your interaction with Docker is going to be with the Docker command line tool. So it's the primary client that you use to interact. And when you run Docker commands, you're talking to what's called a Docker host, or sometimes called a Docker engine. And that is usually local. And so when I show you what I'm doing here, I'll show this all local. So I run Docker commands, and it's running and starting and stopping containers on my system. But that Docker host doesn't necessarily need to be on the same machines. That's why it's pictured this way as different boxes. And images are, and we'll talk about what images are in a second. But containers or images are stored in a registry, and so these are places where it's just like our current FlexNet. It's places where people get the images from. And what's special about Docker is it has a special API to push and pull images from a registry, and it does it in a very unique way. So an image is pulled in layers, which means that if actually, I won't get into it. I'll show you. It'll be much more understandable once we see it in action. I did want to show this. I show this mostly for developers in the room who care a little bit more about what's going on under the covers. So even though I mentioned the primary client you use is the command line tool, it's all based on a REST API. So the Docker engine, the Docker daemon or Docker host, whatever you're going to call it, has a REST API. If you were really interested, you could play with it, but most people just use the Docker command line, which is at the end of the day making REST API calls, but it's just this is the low-level architecture, what's going on under the scenes. The good news about Docker is it is super easy to install and get started. If you're on Windows or Mac, there's a thing called Docker Desktop, which you can install. It's a couple hundred meg. It'll install and come up and be up and running really quickly, and I'll show you that. If you're on Linux, there's more of a native install where you're running the Docker daemon directly and so on. So before I show you things, let's get a few terminology pieces squared away too, because this is a common source of confusion as well. The terms image and container are kind of used probably too much and not the right context. So an image in Docker speak is the read-only template for how to run a container. So an image, as we'll see, is basically a big file oh, sorry, is there a question? Okay, no question. No, I'm getting some feedback. Is that me? Okay, anyway, so yeah, an image is thought of as a file, a read-only file. And when you run that image, you're actually creating a container. And so the container is the runnable thing. And I'll show you what that looks like when we do the Docker demo in a second. If you get into the business of building your own images, you do that quite simply, and I'll show this also with a Docker file. And the typical flow is this: you have a Docker file, you run Docker build, that will build a new image, and then when you run it, you're creating a new container that's going to be running. If folks could go on mute, that'd be great. I'm getting some feedback from when I talk. Okay, thank you. Okay, so I'm gonna do a quick demo here. As I said, you should be able to replicate all of this if you just download Docker Desktop. These are some of the commands we'll run, and I'll show you quickly what each of them does, and hopefully you'll get a sense for what people do to get started with Docker pretty quickly. Okay, so let me switch over to my browser here, and I'm gonna see if I can make this bigger. Hopefully you'll be able to read this. Okay, can I ask someone who's not on mute? You can see my Visual Studio Code editor, correct?
Yes.
Great. I asked because I was having issues demoing earlier in the week where only certain windows were showing. So, okay, great. Okay, so let's get started here. So actually, before I do this, let me just show you Docker Desktop. So I'm on Windows here. I installed Docker Desktop, and again, you just Google for it and you'll find it. But what you get is a kind of a long-running application here, and once you install it, you get the core commands you need. You get Docker command line. You actually get kube control as well, and you can start to do some interesting things in here. You can actually run your own local Kubernetes cluster, which is something they've added recently here. And you can actually do a lot of Kubernetes playing all local on your laptop if you want. But basically, this gets you all of the capabilities. What this is really doing under the covers and is running the Docker daemon, and it's giving me a Linux environment that all of my containers are going to run on, the virtualized environment. And so it's hiding all the gorp away from me about having to make sure there's a Docker daemon running. And it just lets me get started super quick. So as I said, you install Docker Desktop, and right away you'll have access to things like the Docker command and so on. So let's see it in action. So out of the box, when you first start, there's a few commands you can use to poke around. You can say Docker images, and this is going to show me what images, what files, what images from a registry do I have local. And here I have none, because I actually cleaned everything out before we started this demo. So I'm starting completely fresh here with a brand new system effectively. So I've got no images. And if I wanted to see if I have anything running, the command to do that, some people ask why it's not Docker containers. It's actually Docker PS, which stands for process status. And again, this gets back to the point that the best way to think about a container is not a whole operating system running. It's really a process that's running on your host. So when I run Docker PS, I should get nothing as well. I have nothing actually running at the moment. So the simplest thing to do is let's run a image and create a container from it. If I just do Docker run hello world, let's see what happens here. I'm going to scroll up here and we'll see what it did. So when you run, so Docker run will do a few things. It'll see if you've got whatever image you've referred to here locally, and if not, it'll go try to pull it from a public registry. And then it'll also create a new container and then start that container for you. So you can kind of see that in the output here. So the first thing it did, it tried to see, hey, is there hello world with the latest version locally? Nope, there isn't. So then it went and pulled it. And in this case, it's pulling from docker.io, which is a public repo that Docker maintains with millions of images that you can play with. And we'll see a couple others when I do a bit more here. But it pulled it, and then it ran it. And so this output here came from the Docker. And so really what it did, it just printed out this hello world, and it printed out some other stuff here. So now if I do Docker images, after I've done that Docker run, I'm going to see now I have a local image that was pulled. You can see some metadata here. Whoever created this created it 14 months ago. You can see it's tiny. And this is the latest tag. Now, interestingly, we ran that container, but if I do a Docker PS, which again means show me the containers, I see nothing. And that's because the image, in this case, ran its process and terminated. So I can say Docker PS show me all containers, not just the ones that are running. And this is going to show me the hello world was created about a minute ago and exited about a minute ago. And so I have this container now with its own ID and so on. And so that's kind of the easiest way to get started, is running some previously created images from Docker Hub. And actually, let me just go there for a second. I'll just show you what you get. So if you do go to Docker, you can just search for Docker Hub. You'll land in a place like this, and you can search for content. I can search for, actually, I don't know if I've searched for HCL in a while. There probably won't be much on here because we're not putting our images here because we want to have our images all in a protected registry, but you can search for anything in here. So if I wanted to search for MongoDB or something, I can find lots of stuff. It's tagged by how many downloads have happened. People can star images, so this provides sort of a reputational type of approach to this. So you can only, if you want to only download containers that have lots and lots of downloads and have stars, then that's probably a good approach. But each of these entries in here, if you click on it, it's going to tell you how to do what I just did with Hello World. Actually, let's do that. Let's go to Hello World, the one I just ran, because that will be, I think, more instructive. So this is the one we just ran, the Hello World. When you go on one of these entries, you'll see they'll usually give you some pretty good instructions. In this case, it's telling me the exact Docker run command I should use, and so on, and lots of other information. And there's versions of this image. If I was on, for example, my Raspberry Pi, and I wanted to run this on the ARM architecture, I would run a slightly different command. I would tag it with ARM or PowerPC or lots of different architectures that this thing can run on. Okay, so let's do something a little more interesting, because running a Hello World is really not that interesting. So I am going to use a different container. I assume most people on this call are very familiar with web servers and web applications, since DX is one. So I'm going to create the most simple web application you can have. So this is a local HTML file I have. Obviously, it does nothing other than print out a heading. And so if I want to quickly run this in a real application server, Docker is really, really good at this. So I can take any of the app servers that I know about, Open Liberty or Tomcat or JBoss, and I'll be able to find an image for those in Docker Hub. Freely available. I can kind of do whatever I want with. So I have this script that's a one-liner, and it's going to run my little web app that contains nothing but an HTML file, and it's going to run it in Open Liberty in a container, and we'll see that in a second. So I'm just going to break down this command a bit because it's a little bit more involved than the previous Docker run we saw, but it's doing some interesting things. So this first part here is called port publishing, or some people call it port mapping. What this is saying is when I looked at the documentation for Open Liberty, it told me that when I deploy my apps here, by default, Open Liberty is going to expose port 9080 for traffic. And so that's, again, because every container has its own isolated view of everything, including network, that port is actually not available to my local host, even though I'm running the container on the same machine. So I need to publish that port to my local host. So in this case, I'm going to say, yes, it's port 9080 to WebSphere, but on my local host, on my Windows machine here, when I run it, I want to access it on this other port. I could have chosen the same port. I could have said 9080:9080, but just to make it different, to show there's an ability to change that, I use a different port here. So we'll see what that looks like when I actually run it and access it. The important part here is this -v, which is doing a volume mount, which says, take this local file path, in this case, it's where my index.html lives, and map that or mount it inside the container at this location. And so the way this works is Open Liberty is always looking in this folder it knows about, config drop-ins, for anything that's new. And so by running this command, it's going to create a new folder in there called myapp.war, and that folder is going to contain this index.html file. And then I'm also giving my container a name, because that makes it easier to run subsequent commands against it, like starting and stopping it and other things, which we'll see. And then the last piece here is, what is the image that I want to use? And again, this is just from Docker Hub. You can search for Open Liberty. You can find all kinds of images and various flavors of it. But that's it. This is the command where I'm going to run my application here in Open Liberty. So let's see, I'm in the Docker. Yeah, so I'm just going to run this. This is going to, I'm going to start to see some output here. I mentioned earlier that Docker images are pulled by layers. That's what you see happening here. So the Open Liberty image that I referenced is made up of several layers. And so what's happening here is each of those layers is being pulled locally to my machine. A new container is being started, and now it's in the process of starting up. So now we're starting to see some Open Liberty logs. Anyone who's played with Open Liberty will probably recognize these. And so my app's starting up here, my process is starting up, and it looks like we're good to go. So I've got the server is ready to run a Smarter Planet, which is what Liberty usually says when everything's up and running. So if I now go to my browser and I go to localhost, and if you remember, we mapped it to port 9082. If I just go there, I'm going to see, yep, I've got Open Liberty running. And by default, Open Liberty will create a path to the app here. So this is now running in a container, but it's serving up content that actually lives on my local host, because this volume mount, it's not a copy of the file. This is actually, the container is referencing the file on my local disk. And to show you what that means, if I go back to my local file system here and I change this and save it and go back to my browser and refresh, the changes are live. So even though this is in a container running in its own isolated network with its own set of things, because I did that volume mount, it is actually sitting on top of that local file system. So this is one of the reasons Docker is so tremendously powerful for development teams in particular. If I want to develop a new web app or actually a new application of any kind, I can have the code local and I can have all of the language specific stuff in a container. So I don't need to pollute my Windows machine here with, for example, Java installs or Node installs or any other installs for language dependencies. I can put all of that in a container. I can run it, start it, stop it, and still have my code local and use my favorite local editor here. So this is one of the first things that development teams really latch onto as a key value of containerization. I'll just stop there. Does it make sense so far? Any questions or confusions? I'll take silence as a no. Okay. So, but let's do something more interesting. So, let's say we've built up our application that we. Oh, and actually, let me do one other thing. I'm going to create a new. I'm going to Control C in my current command prompt to get my command prompt back. This did not kill the container. This just killed my attachment to the container. So now if I do a Docker PS, I'm going to see, I don't like the way that's going onto a separate line. Maybe I'll make it a bit smaller. Hopefully that's still readable. But yeah, so Docker PS now is showing me actually there is a running container now. Here's the image it's based on. It was created 3 minutes ago. It's been up for 2 minutes. I can see information about the port mapping. So, you know, I wanted port 9082 locally, and that's pointing to port 9080. That name I gave it in the command with the -- name, that's what makes it really handy. So for example, for any running container, I can do things like this now. I can do Docker logs, my app, just show me the running standard out logs that have been accumulating since it started. And that's one of the nice things about Docker and Kubernetes is they sort of automatically retain logs for containers for the long haul. So this is the full set of standard out logging that Liberty did. So at any point you can get to that. Also, again, if I do, let's just go back and do Docker images. Now we'll see I have 2 images locally. I've got that one from the Hello World we did with the first run, and then now I've got my Open Liberty local again. So now if I run another Docker run with Open Liberty, I'm not going to incur any of that download cost. This image that's been cached locally here is going to be used for my next container that I start with Open Liberty, which is one of the things that Docker really shines at, is this local caching and quick development turnaround. Okay, so some other things you can do just quickly here. If you want to follow the log, so let's say you've got a long running application and you're interested in what it's doing, you can do Docker logs -follow. And this is going to sit there. And if there's a new log entry that Liberty spits out, it'll show up here on my command prompt. So it's basically a way to watch what's going on, which is also helpful. Really helpful for troubleshooting is maybe if you're the developer of this image and something's not working and you want to get in and see what's going on, Docker exec is one of the most powerful tools that you can use. So it means execute a command inside your container and do something. So the most simplest way is to do something like execute in the container my app. I happen to know inside Liberty there's a server XML in this location. So show me the output of that server XML. So that's it. So this is going into the running container and running this Linux command. And so I can run anything here. I can do ls and just show me, what's in the current folder and so on. Even more powerful is I can run an interactive shell with -it, and I can say run bash. And this is going to land me now in a shell where I'm actually in the Liberty container, and I can poke around as if I'm fully logged in. And so now I can do lots of interesting things right here at the command line, like I'm inside Liberty. So that's really powerful, obviously. And then I just exit to get out of that bash shell. One last thing is, let's say there's some configuration file or something inside Liberty that I want to get out and pull locally, so I can open it in my nice editor here. There's a Docker CP or copy command. So you do something like this. You'd say Docker myapp config server XML, and then the place you want to store it locally. So I could say cached server XML, and that's going to go into the container. And you can see it's already copied it locally here, but this is going to grab that file and store it locally on my file system, so I can go do things later. So lots and lots of troubleshooting help that you can get. Oh, one other thing I'll show you, which is useful. As I mentioned, Docker containers really are about running a process. So you can run the Linux command top, and they actually provide that as a top level Docker function here. And when I do this, Docker top, it's going to show me the processes running in this container. And this is going to show me from a Linux point of view what actually got invoked when Liberty got started. So I can see the full command line here. It started up a Java process and set some Java properties, and here's the exact setup. So again, if you're in the business of a container, this is something you'll probably be interested in. Okay, so let's say now I'm happy with my web application. Now I want to actually package this thing up. I want to package up my fancy web application here into its own image, so that I can ship this to users and they can just do a Docker run, not worry about volume mounting, just do a Docker run and have my app pre-deployed in Open Liberty. That is about as simple as it can get. So for that, we need a Docker file. As we mentioned earlier, a Docker file is basically it's a simple text file with a bunch of commands in it that tell Docker how to build up an image. And so in this case, this is about as simple as a Docker file can get. You can get much more complicated than this, but in this simple example, we're just doing exactly what we did in the Docker run command. We're starting from a base image, the same one we used in Docker run. And this time, instead of volume mounting, we're copying our local file here, our local folder, into that same location that we previously did a volume mount to. And so this is going to, and to build this thing, I would just, let me see, am I in the right folder? Yep, Docker files here. So to build a new image is, again, just a one-liner. You say Docker build, you give it the folder where your Docker file lives. In this case, it's in my current folder, so I just say dot, and I tag it with some name. So I can say my app version 1.0.0. And that's it. So this is now going to go, it's going to make sure, because again, we set up here from Open Liberty Web Profile 8, it's going to make sure it has that image locally, and then it's going to go build my new image, and we're done. So if I say Docker images now, we can see in my local cache, we now have the image that we just built, my app version 1.0.0, created 6 seconds ago. You know, not surprisingly, it's the same size as the other one because we added almost nothing to the Open Liberty, but this image is now runnable on its own. So I can do this now. Docker run, I'm going to do -d this time, and I'll show you what that means. It means detached mode, which is a different way of running images, but also helpful. This time I'm going to map a different port, so we'll do, let's say, 9081 to 9080, and we're going to give this container a different name. We'll call it myapp2, and then we do the image that we want to actually run. So it's the image we just selected. So I run that, and it should be up and running. In this case, you'll notice we didn't get any of the Liberty logs or any of the other starting up logs. That's because of this -d flag. It means run in detached mode. It means return immediately to your command prompt, but behind the scenes, the container has been started up and so on. So if I now do a Docker PS, I'll see actually now I have 2 running servers, and one's at port 9082, one's at port 9081. If I go now to my browser and go to 9081, I'll see it's also running there. And the difference now is it is actually using content that's been copied into the container. So if I change my file back to Jeff here and save it, this one will stay as Mary because it's the one we just deployed with the packaged version of the app. If I go back to 9082, the one we started with, it's going to be what I just changed it back to, Jeff. Right, so, and this, again, so this is the next flavor of really interesting value that developers get out of Docker. I now have 2 versions of the same app server running on my machine, completely isolated from each other. So this is really valuable when you want to replicate, for example, an older version of the product you're working on, or you want to maintain demo environments of previously shipped products. You can just store images of anything you want and run them. Oh, and I didn't show you start and stop. So at any point, I can do a Docker stop, and we'll stop the one we just started. My app 2, I think I called it. Yeah. So now if I do Docker PS, we'll only see the one we started initially. If I do a Docker PS-A, we'll see the one we stopped in here. And now I want to show you one thing that's interesting. If I start that one we just stopped again, I don't have to specify all of that port mapping stuff. That's persisted as container configuration. So once I've created a container once and given it a name, I just start it like this, and it will start exactly the same way it started before. And there's a really interesting piece about the logs that I'll show you here too. If I now get the logs of my app 2, we're going to see 2 sets of logs. We're going to see the original set that was from the first time we started, and then the second set, all because again, Kubernetes and Docker persist all the logs from container restarts. So you know, if this container started 10 times, I would see 10 sets of logs here. So really, really useful for troubleshooting and so on. Okay, so I didn't want to spend too much time on Docker. Hopefully that gives you a flavor for what you want to think about if you're going to try it. I would highly suggest, if you've got time, install Docker Desktop and start playing around. One of the really exciting things about this space, Kubernetes and Docker, is because so many people are doing it, there's so much to find on the internet. It's just a Google search away. All kinds of interesting uses of this that I didn't even touch on, that in lots of different ways of leveraging the technology. So yeah, highly recommend. And I believe most people on this call are in field technical advisor roles. So as I mentioned, one of the real beauties here is if you are in the business of regularly showing demos to people, or you just need an environment stood up quickly, you can containerize those things if you're able to, and start and stop them on demand really quickly. Okay, so let's go back to the, actually I'll stop there. Any questions on Docker? Okay, so Kubernetes. Once a development team, because usually the way Docker and Kubernetes get started in a company, it's usually not from an executive mandate. It's usually from some curious development team getting started with Docker and seeing the value, and then it grows from there. And the way it grows is, as soon as you've created one or more containers, you start to ask these types of questions, which all lead to Kubernetes. Things like, okay, well, what if I containerize my web app and I containerize my database? How do they talk to each other? Or how do I, if I've got multiple containers, do I have to script all of this Docker start stuff and start them independently, or is there a better way to do that? And so on. So lots of questions like this, as I said, all lead to Kubernetes. And so I always show this chart, and I only show it because I want to make sure people don't see this in the wild and get scared away from Kubernetes. If you Google for Kubernetes, you more often than not land on a chart like this. And you, as an end user of Kubernetes, you need to know almost nothing about this chart. This is the underlying architecture of Kubernetes. And so under the covers, when you deploy a cluster, this is what happens. And so each of these things over here in the node section, each of these is essentially, think of it like a VM with a whole bunch of stuff running. Kubernetes calls them nodes. But the fact that the process that Kubernetes runs on a node is called kubelet or kubeproxy doesn't matter to you. So if you ever land on charts like this, feel free to just ignore it. And we'll talk about the stuff that matters on the next couple slides. So for real end users, what you're usually doing, and we'll show you this, is you're doing a declarative approach with Kubernetes. Kubernetes is a really interesting platform. Its goal in life is to take in configuration from you, where you're telling it, hey, I want the system to be in this state. And the state can be things like, I want to make sure there's 5 versions of my, or 5 copies of my container up and running for scalability purposes, or I want to install this application or something, some state. And Kubernetes is always listening. And when you make these kind of changes, and you do that by applying new YAML into the system, and we'll see what that looks like. When you actually do this, Kubernetes wakes up and says, oh, there's new configuration, and then it goes off and does a whole bunch of work to get you into that state. So the reason it's kind of a declarative approach is you're saying, here's the desired end state, and Kubernetes will eventually get you into that state. So it's not like you sit and wait necessarily for your end state to be perfectly golden. You're basically telling Kubernetes, here's where I want you to be, and go do all the work required to get there, which could be installing containers, starting or stopping other things. And the real value of Kubernetes is if something goes wrong in the future when you're not looking, like some pod or some container fails or something, it will then wake up again and try to get you into the desired state. So if one of your containers, one of your 5 somehow fails, it'll try to restart it automatically to get you back, always trying to get back to that desired state. So the key objects that you do need to know about if you're going to do Kubernetes are listed here, and there's some others, but the key ones that we're going to wrap our heads around here are pods and services. I won't talk about namespaces much, but deployments and others. So we'll see these in action in a second. And one of the really nice things about Kubernetes, which I just mentioned actually, is even if you think that as you're trying to deploy something to Kubernetes or try to solve some production grade challenge with your application, so many people have already paved the way here. So most challenges that you think might be unique to your product are typically already solved in some way, and they're usually just a Google search away. One of the real powers of sitting on top of open technology is there's just so much resource out there to borrow from. Okay, so rather than start from the top down or from some bunch of words to describe what the core objects are, let's try to do it graphically. And I like to build from the bottom up, because most people come from a basic understanding of Docker and containerization. And so Kubernetes takes that and abstracts it away and adds a whole bunch of other abstraction layers to make the system work. So let's talk about what those are. So let's say we've built a container that maybe surfaces some REST API. So maybe it could be exactly like that Open Liberty container we just built, but instead of hosting a web app, maybe it just serves up a REST API. And that's all it does. And maybe it's stateless. It can come and go. It just serves requests and returns results. What Kubernetes does, there actually is no object in Kubernetes called a container. The lowest level of abstraction in Kubernetes is called a pod. And a pod is basically a runtime environment for a container. You can have multiple containers in a pod, but usually the best mental model is just think of a pod sort of roughly equals a container. So in this case, to deploy my REST API container to Kubernetes, I'm going to wrap it in a pod object, and we'll see what that looks like. A pod gets its own IP address and its own port, so it's addressable inside the Kubernetes network by other things. But the really important part about pods, and actually containers in general, is the best way to think about them are to think about them as completely ephemeral. So Kubernetes makes no guarantees that it's going to try to keep your specific pod here up and running. In fact, based on what's going on in your cluster, it can decide to shut it down, restart it, do all kinds of things to it. So you need to build your containers as if they might get killed and restarted at any point. And so that means, and when a container or a pod is killed, that means all the data inside that container's file system goes away. So if you do have persistent data, obviously most useful containers do, those need to be handled separately with persistent volumes in Kubernetes, which we'll talk about in a second. But as you're building your containers, you think about them as ephemeral. They can come or go, someone can delete them, restart them based on what's going on. So, but just deploying one pod on its own is really not that interesting. All you're doing is really deploying your container to Kubernetes, and that's not much more useful than doing it on your laptop and deploying one container or running one container or doing a start like we did. So Kubernetes has a really useful abstraction called a deployment. There's other flavors of this called replica set and daemon set, which we won't get into, but the basic one is a deployment. And a deployment says you're gonna deploy one or more replicas of a given pod. And so what you can do with the deployment is you can say, actually, I want 2 copies or more. You could have 100, but in this case, I want 2 copies of my pod available at all time. And you declare that in your deployment. And again, that's just more YAML, which we'll take a look at. But the key object here is, from a Kubernetes point of view, is the deployment. It says, here's the pod, here's the image to use, and make sure you've got 2 of them running at all time. And each one gets its own IP address and its own port that it exposes traffic on. So the problem is, if you were trying to build some service that consumed or tried to call this REST API, the problem is now your service needs to know these IP addresses and ports. And again, these can come and go. Think of them as ephemeral. So, maybe tomorrow 10.0.0.2 is not going to exist. There's going to be a new one because that pod was killed and restarted. So that's just chaos for someone trying to call this REST API. So Kubernetes comes along with yet another abstraction called a service. And in this case, a service is the persistent endpoint, IP address and port, that exposes pods, function in pods. So now it's not the individual pods that you're talking to, it's the service object. And again, pods can come and go. And because they all have this label, and this is the magic that hangs it all together, and we'll see this in the YAML file, but each pod says, here's my label. In this case, it's a simple label, my app. And the service says, I'm essentially serving all pods that have that label. So that's how it knows what pods it can use to direct traffic to. So for example, if 10 more pods get stood up with that label, now the service has 10 more pods it can direct traffic to. And again, this IP is still internal to the cluster, the service IP, but it is persistent. So it is the long-running thing that consumers of this function can depend on. Okay, so now we want to expose our traffic to clients outside of the cluster. So everything to this point has been internal cluster IP import. If we want to expose something externally, Kubernetes has a concept of an ingress. And this is where you can have various types of fronting services, but you can expose, for example, a public IP address and port, and you can route requests based on the incoming HTTP request to various services. And you can have more than one based on the incoming request or URL. So in this case, the clients of this function, it's just like any other web application. They're communicating with a public IP address and some known REST API format, for example, but they have no idea that behind the scenes this is Kubernetes and there's services and pods exposed. So the ingress is really the thing that that clients connect to. I mentioned I mentioned earlier that stateless is kind of what we're talking about there. It's the easy approach. When you do have containers that need to persist data, So for example, if Kubernetes decides to shut down my DX container and I don't want to lose all my data, all of the stuff that's considered part of the user data or generated data in DX needs to be persisted. So that's done with a couple other abstractions. One's called a persistent volume and one's called a persistent volume claim. So Kubernetes has intentionally abstracted away from pods how their storage is provisioned and managed. So all a pod does is says, I need some storage that meets these requirements. And so in a persistent volume claim, a pod will say something like, I need, this type of storage, maybe NFS or something, and I need 80 gigabytes or something like that. So it's making metadata claims or requirements against the storage, but has no idea how that storage is going to be provisioned or managed. Kubernetes then sees a new persistent volume claim and will go try to see if there's existing storage providers configured in the cluster to support that claim. And if so, it'll go do that provisioning, or you can do it manually, but Kubernetes will do it dynamically if necessary. And it will bind that back in. So from a pod's point of view, when it starts up, it has a persistent volume claim. It says, I want some storage of this type and I want to mount it at this location in my file system. And when it starts up, it has no idea how that was done. It just knows that there's a file system there to start interacting with. And when that pod goes away, it's the same pod configuration that Kubernetes is using to start up again. So it's that same persistent volume claim. So that's how pods can start and restart and have access to their persistent data. Hope that makes sense. It's a really complicated topic, actually, once you start to dig into it. And so this is one of the things we work with most of the product teams on to try to figure out the approach here, especially taking legacy apps, which have kind of important files stored all throughout the file system, or important files stored, and trying to figure out how to do proper persistent volume mapping. Okay, and before we start doing the hands-on part, I wanted to talk really quickly one slide about Helm, because we will be using that. So as we'll see when we start doing the hands-on, deploying stuff to Kubernetes is really, really low-level configuration file-based interaction. So you're typically editing YAML files, which are not that easy to read or edit, and you're deploying those things and reading and writing them from the cluster. So Kubernetes a couple of years ago, in combination with some other people, came up with Helm, which is their default package manager. Now it's off on its own project. And a Helm chart, which is what the term they use for basically an application bundle. A Helm chart is really just a big tarball of Kubernetes YAML files that make up an application. So it gives the end user a simple way to install what could be a arbitrarily complex application made up of dozens of different YAML files. Some of them are hundreds or thousands of lines long. The end user is just doing a simple one-line Helm install command. And so we'll see that, and we'll see what that looks like. In the, if you guys want to open, I put some documents in the team chat file area in the general channel. I'll just open them myself so you can see what I'm talking about here. So there's now a collection of files here. We're going to start, and if you ever need those slides that we just went through, that's this PowerPoint deck here. So we're going to start with the GCP setup doc, and so you can open that or you can just follow along with what I'm doing. I'm going to do this as well myself, create a brand new user from scratch, so if anyone sees any issues, I'll see the exact same ones. Okay, so so what we're going to do here, and again, I'll explain why we're doing this, but we want to give end users, as the clients, in this case, like Bill and I talked about at the beginning, clients like PSCU, which are just getting started here, we want to make sure they don't get the impression that Kubernetes is hard, or that it's going to be this mountain of IT effort to get started with. So to just get started with the basics, the cloud providers, especially GCP and GKE, make it extremely simple to get started. And so what we did with PSCU, and we're starting to pitch this more with others, is we actually suggest just go out and get your own Google Cloud Platform trial account and try it out. Google actually gives you $300 US dollars. So for Canadians like me, that's 480 Canadian dollars. They give you that much in credit, and so you do have to specify a credit card when you sign up, but they make it clear they will never charge your credit card unless you manually or explicitly update your account from a trial account to a paid account. So, and what we've seen in practice is you can go for weeks or months of doing real Kubernetes stuff before you burn down that $300 anyway. So there are activities going on in HCL to get people tied into a broader real GCP account. Once that's in place, then everyone should have their own credentials and log into a central place, but that's still in the works. So for now, and for our external clients, this is what we're pitching, and it went very well at PSCU. So for those that are able to now and are comfortable putting in their credit card, we can go through that process. And if folks aren't comfortable doing that, they can just follow along. I'm going to be doing all the steps live here, so you'll see all the stuff also. So questions before we get started? Okay, so let's get started. So I am going to take this link, this first link here. I'm going to start a incognito window because I'm logged in other places. So first step is to go to the link that's in the document, which is the main page for Kubernetes, and you land on this page. So if you've already tried out GCP and you have an account there, you can just enter it here. I'm assuming most people don't. So you're going to come down to the create account section, and you're going to say it's for myself because we're not going to set up business accounts here. And so you land on this page for creating your new Google account. You can actually use your HCL email here, and that's what I've done, but I'm going to create a brand new user here just to start from scratch. So you can create your own Google account using your HCL email, or if you've got a existing Gmail account, you can do that. Or if you want to create a burner account just for this, you can come down here and say create Gmail account instead. And so you give your name. I'm going to make up some, let's see, what haven't I used yet? Test 5, we'll call it. And give it a password here. Okay. Put in my phone number because it's going to ping it and ask for a confirmation code. Guess it wants this, whatever. Okay. Okay, so now it's going to land me on verifying my phone number. So I'm going to say yes, send me my code. I'm going to get out my phone here and wait for it. Okay, got my code 618117. Verify. I'm going to skip all this other stuff. I'm going to accept the privacy terms. Okay, and once you've got through the initial sign-in process, you should land. Oh, actually, it's going to say what country am I in? Sure, I don't want to read any of that stuff. Okay, so if folks were able to get this far, you should land in the clusters view. And so this is in the Kubernetes engine. I'll show you some of the navigation here because this is the entire Google Cloud Platform, all of its services that you have access to when you sign up. But here we're just looking for now at Kubernetes. And so this is the clusters view. Everything in GCP you do is based on a project. And so we don't have a project yet. And so we need to create one. So I'm going to create a new project here. I'm going to give it a name. And one little tip, I'm gonna call it my last name, turn one. It generates this ID here. I think this has to be unique across clusters, but if you can change the ID. Yeah, it does. Okay, so I'm gonna make it something else here. Yeah, okay, so now I have a nice ID that I can use in future commands. It doesn't really matter, but it sometimes helps to have the ID you use in Kubernetes commands be readable instead of the generated one. Okay, so I'm gonna create my project. This takes a little bit. Anyone having issues so far, or folks able to follow along? Okay, so once we've done that, okay, so I got reverted over here. Okay, that's interesting. Okay, so it seems to have redirected me to my project homepage. So I created my new project called Turnham 1234, and this is the dashboard for everything you might want to do in GCP. As I mentioned, by doing this, you get access to everything in Google Cloud. This is every GCP service they make available. So lots and lots of stuff in here. They have a really helpful UI trick here to help you focus in on the stuff you need. So if you scroll down a bit, there's the Kubernetes engine, press the pin icon, and that will put it up at the top. So the stuff you care about, the sections of services you care about, you can pin them and they'll be at the top. The other one we're going to use, and you don't have to pin it, but it helps, is you go down to VPC network. So we're going to set some security later, and you pin that. So now I've got these two things at the top. If I go back to my clusters view, this is where now I have to sign up and put in my account information, because to create a cluster, it's actually going to go provision VMs. And so I actually start using GCP resource at this point. And so here, I'm going to sign up for a free trial. Yes, I'm in Canada. Again, so if you haven't seen this before, doing this gets you access to all the cloud platform. As I said, you get $300 in US dollars to spend, and if you burn that up in 12 months, then you'll be blocked, unless you update to a paid account. But as I said, this is plenty to get started with Kubernetes, and this is the important bit. Even though we're going to put in a credit card information, you're not charged unless you manually upgrade to a paid account. So hopefully this makes folks comfortable enough doing this. Okay, so I'm gonna do this. I always say individual here. I'm not sure what the account type matters or not, but because this is just an individual experiment, I put that in. I'm gonna stop sharing my screen for a second while I put in the credit card information. I'll share it back when that's done. One sec. Okay, so hopefully you can see my screen again. So I went through, I put in credit card information. Now I land in this page. It takes a few minutes actually for this Kubernetes Engine API to be enabled. And so I think they're setting up accounts in the background and all kinds of things. When I tried this earlier in the week, it was, I think, 2 or 3 minutes to get started. So if folks want to get to this point and maybe grab a coffee or something, we can continue on in a few minutes, or if there's other questions or comments, we can have those discussions now.
So what are we doing in the Kubernetes engine? We're creating a cluster?
Yes, we are going to create a brand new cluster, and we're actually going to deploy DX there if you like, or you can deploy other things, and we'll do some other tests in there. So we'll show you how to interact with Kubernetes and how to debug things and all that good stuff.
Is the Google Cloud Platform currently the only Kubernetes environment that we are able to deploy stuff onto, or do we already support other platforms as well?
Yeah, so it's kind of that question varies by product, but for Sophie, for the stuff we're doing, and we haven't seen Sophie yet, we'll get there shortly, but we support GCP and AWS, and we've tried an OpenShift and it works. Basically, our position is we're trying to be as cloud agnostic as possible, and so we want to support deploying into any Kubernetes environment. Actually, at the beginning, I mentioned we have a business partner in Italy who's doing some stuff with our beta. They deployed content we have in Sophie into their own Kubernetes bare metal installation. That they use a vendor out of Italy called, and then the distribution is called Kubernetes Fury. So it's something we had never heard of, but they were able to install and get things working. They had a few tweaks to make, but in general, over time, we expect to broadly support all the big platforms, and for any niche Kubernetes environments, we'll document how to get those working as well.
So Jeff, one thing that I'll add, sometimes I get questions like, how much does it cost to run this? Like, we get $300 worth of credits. It totally depends on, what size and what services you have running. But when I did this workshop a few weeks ago, I signed up for the developer account, got my credit. I did the workshop and deployed, and then I forgot to turn it off after the workshop. And a few days later, I realized, oh shoot, I've been running this for several days now. I hope I haven't racked up a bunch of charges. And my account went from 300 down to 272. So it looks like it's around $7 to $10 a day to run a Kubernetes cluster that's DX sized. So yeah, you definitely want to just have it running while you're using it and then turn it off when you're not. If you do that, it's going to last for a long time. If you don't, it'll last about a month.
Okay, so my spinning wheel saying Kubernetes API enablement has stopped. So I don't know if everyone else's has. If not, I'll go pretty slowly here. And you can kind of just watch what I'm doing and then catch up, because there is going to be another delay here when we create the cluster. So I've got the steps documented in that document we were just looking at, but there are a few things you want to tweak in the default cluster creation dialog here. So the first thing is give your cluster a name that you like. I'm just going to call mine Jeff for now. You can leave the rest of the defaults on this page the way they are, the cluster basics. The important parts to focus on are the node pools, which are basically saying what types of VMs do we want to stand up, basically the worker nodes in Kubernetes, what kinds of VMs. And this is where the cost comes in, because again, you are essentially telling GKE or GCP to stand up specific types of VMs, and they're going to be running workloads. So that's going to be a compute cost and other things. So the first thing to change when you come to the default pool is actually, because we're going to do DX and because we're limited in the trial account to a certain number of CPUs, it's important to change this to 2 because we're going to have kind of beefier nodes. And so change the default nodes from 3 to 2. That's the first change. And then on the nodes page itself, come down to the machine type. And if anyone's ever stood up VMs, this is exactly what you'd see in VM provisioning. But we want to pick a specific one because we know it supports DX, for example. So there's one called N1 Standard 4, and it's got 4 virtual CPUs and 5 gigabytes of memory. So we're going to have 2 of these things because we set that default to 2 earlier. So basically, we're going to have 8 virtual CPUs and 30 gigs of memory total available in our cluster. And I think that's it. Let me just double check, make sure I didn't change anything else. Create Kubernetes cluster. Yeah. Okay. So once you made those 3 changes, you can just say save or create, and it'll go off and create it. This will take a minute or 2. to create, and when it's done, you'll see a nice green check mark beside your cluster name saying it's ready to go. And again, if anyone has any questions while they're either trying this or watching me spin here, feel free to ask them. One minute.
How big these images should be? Is that what Jeff just did, the official recommendation, or how does that work at the end of the day?
Hey, I just got back, so I think I got that question. Is it how do you size your cluster? How do you know how to size it?
Yeah.
Yeah. So basically what we're doing here is we are trying to size our cluster to maximize this trial account. In practice, the way this works is administrators don't want to set up many clusters because it's a kind of a pain, as you can see, to do so. So what they do is they stand up beefy clusters, big, huge ones that can support all kinds of workloads, even from different teams. And one of the nice things about Kubernetes is you can isolate teams into their own namespaces. We didn't really talk about those, but everything you do in Kubernetes, every object you deploy, every application you deploy is done so in a namespace, which is isolated from other namespaces. So you can fully support and have different access control for teams where they can only see stuff in their namespace. So it's a best practice for Kubernetes administrators to stand up beefy clusters and support many users rather than trying to create kind of clusters that just barely fit workloads. Okay, so I have my green check mark. Has anyone else got this far yet? Anyone else have a green check mark for their cluster?
No, not yet.
Okay.
Mine just
We'll give it
didn't.
a,
Not yet. Now it got, yeah.
sorry, you did get one?
Yes, mine is green now.
Oh, great. Okay, so I will continue on again. We won't be going too fast here, so if people need to catch up, they should be able to do so. But one of the most useful features that Google Cloud has, and the reason we like to focus on it from a especially out of the box point of view, is that it's just so easy to use entirely in the browser, and then you can get more advanced later. So you'll see a connect button on the right. Hit that, and there's a set of stuff you can use in here. This first command here, if you've got your own kube control command locally installed, so for example, if you've installed Docker Desktop, then you would have to install this other thing called gcloud, but it's also easy. But once you've done that, this command, if you run it locally, will connect your local laptop into this cluster so that you can do things. But that's a level of installation and configuration that is sort of a blocker for some clients to get started, because who wants to install something they don't know much about on their laptop? So Google Cloud provides this really powerful thing, run in Cloud Shell. So we're gonna pick that. That's gonna bring up, after you say continue here, that's gonna bring up essentially your own little shell. And what's actually happening under the covers here is it's provisioning a small VM that we are now logged into, and this VM has all kinds of stuff pre-installed on it. It has kube control, it has Docker, it even has stuff for development teams. So actually I'll show you. So when you come up here, it comes up with this command, that same one we saw earlier, pre-populated. So you have to press enter, and this will connect me into the cluster. So now I can do things like kube control, get pods, and show me all namespaces. And this is going to show me all of the running pods in my cluster. And you can see there's more than a dozen here that were set up. And this is part of the Kubernetes infrastructure, which we don't really need to care about for now. And you can see these are in a namespace called kube system. So if I didn't say that -a, it would say no resources found, because by default, commands where you don't specify a namespace will it defaults to what's called the default namespace. And so we have no pods running in the default namespace at the moment. But what I wanted to show you was this VM we're running has, like I said, all kinds of stuff pre-installed, and Google keeps this up to date. In fact, we've asked for some updates for stuff installed in here. So for example, I can do Java full version, and there's a, is it just one? Yeah, so we've got OpenJDK 1.8 in here. We have Node in here again, or obviously that's 2. Yeah, Node's in here. There's PHP, all kinds of stuff for development teams to kind of quickly get started. It has some other interesting capabilities, which we're going to use as well. Things like if I want to upload a file in here, let's say I've got some YAML file, and that's actually exactly what we're going to do, where you can upload files, you can edit files, there's an edit capability as well. So lots of cool stuff. So the first thing that we're going to do, let me just bring up where is it? You bring up the other document. We're going to come back. If you were following along in the setup document, we're on step 3 now. So we're going to run a set of commands to set up the cluster even further to be ready to install what we need. There's a few things we need in there. And then there's a 4th step about security, which we'll come back to later. I guess the numbering's a bit weird here. There's 2 number 3s, but anyway, okay. So we've done this first part. We've looked at pods and other namespace. These next set of commands, you literally should just be able to copy them in. We've considered making this all a script for users, but users are typically a little skeptical of scripts that they are going to just run. So instead, we include all the commands. We're actually going to get rid of some of these commands, or we hope to. And so for now, we just let you, or make you, why can't I copy this? We make you paste them in here. So basically, yeah, you just copy it, you come back to your browser here, and Control-V will paste it in. And this first command is going to install Helm version 3. By default, actually, Helm version 2 is installed in this Cloud Shell, but we're going to use 3. That's the latest and greatest. So that's the first step. And then, yeah, you just go through and paste in the other ones, which set up a few other things. The key one for us is Cert Manager. Oh, why am I? Okay. Yes, so once you've done the Cert Manager ones, the important one for actually being able to deploy stuff that we have in Sophie is going to be the next one. And this is where you're going to pass in the Artifactory credentials that you were sent earlier. And if you've changed your password, you would need to do that. So your Artifactory user ID is going to be your email, your HCL email ID, and your password is going to be either your default one that you were sent or the one you passed in. So I'm going to unshare my screen while I do this.
So is the basic idea behind these steps to set up your cluster so that it is then able to pull an image from an external resource in a secure way down into the cluster and run it there? Is that what we're setting up here?
Exactly. Yep, you got it. So Kubernetes pulls images from wherever you wherever it needs to, and if it's an authenticated registry like ours is, yeah, you create these image pull secrets, and Kubernetes it maintains a list of them, so it'll try several different ways to download your image, and if it can't, you'll see a failure in your cluster deployment or your app deployment.
So for this user ID, the Artifactory user ID is your Google account then?
No, it's your HCL email. It's the credentials you were sent in the email that you got earlier from me.
Ah, okay.
Okay, I'm done with that. So I'm gonna share my screen again. Okay, yes, so whoever it was that asked that very astute question about what we're setting up here, this next section kind of shows we're not going to run this home install yet, because we're going to flip over to Sophie and create something to install. But basically what we did above is we created an image pull secret, it's called, and we called it Sophie Secret. And that essentially contains our credentials and stored off in another object Kubernetes has called the secret. And then whenever we install something from Sophie that has images that live in our protected Artifactory registry, it'll pull those from there. And the way we do that is we set this environment variable, because we actually support our HCL product images living in a variety of places. They could be in Google Container Registry, they could be in Artifactory, they could be local. So you can override a Helm install to say, here's where you need to pull from. And in this case, we're saying, here's the name of the secret that we've already created in Kubernetes that you should use to pull from. But if that doesn't make sense, it hopefully make more sense once we actually install. So I'll give folks a minute or two more to catch up there, and then we'll switch over to Sophie and start creating something.
And the Helm install for the MyDX, that's something we actually will do with Sophie instead, right?
Exactly. You're gonna create your own solution called whatever you decide to name it. And this MyDX is just a Helm release name. This can be anything that you use to refer to it in future commands. But yeah, basically we're gonna go to Sophie now. We're gonna create our own solution that's got DX in it, and then you guys can all deploy it and make sure it gets stood up in your cluster.
Okay, yeah, makes sense. Thanks.
Okay, so hopefully folks are close to following along. If not, again, this is recorded, so we can always catch up later. Okay, so hopefully everyone has been able to get to Sophie Dev and able to log in there. I'm going to do that now with my own credentials. We should land on a landing page like this. I suspect not everyone here has seen Sophie, so I'll just give the quickest demo ever, and then we'll dive into actually creating something. So basically, Sophie is about creating that cloud native application catalog we talked about earlier, where you kind of quickly and easily discover stuff that HCL has to offer. For example, if I want to know what database capabilities are had, I could search for data up here, and my list would get filtered to everything that has to do with data. Or if I was interested in testing tools, I can type test and see what's available for that as well. Each of the cards here has a learn more action where I can go see more information about it, with some in particular information about how to both install it and use it once it's actually installed. The categories at the top here are kind of important. I mentioned at the top, when we first started Sophie 2 years ago, we were really focused in on microservices. We said, let's take capability and function out of our legacy products and surface it in these new ways and make it an easily consumable and consistent catalog of microservices that I can pick and choose from. But as we did, and we did that, and we have lots of them in here, but as we did that, we realized that there's also tremendous value in just containerizing our entire legacy products and making that and also a very easy install experience. And so we have a bunch of products, full products in here as well. So that's a differentiation here between services and products. We have this other tab with nothing here yet. We have some stuff coming for integrations. This is where we think there are obvious integrations between some of our products, like for example, Commerce and DX, or Urban Code Deploy and Urban Code Velocity. We want to have pre-integrated versions of these things that are deployable just as easily as anything else in the catalog. So I can, with a one-line command, say deploy Urban Code Deploy and Velocity. Both of those things get installed, and all of the glue, the configuration scripts, and everything that ties them together is also run. So I don't have to do that myself. So that's what that tab's for. And then we have another tab, which is grayed out. We haven't done anything here yet either, but this is for if someone's gone off and built some pre-existing entire solution, which is meant to be a packaged application based on Sophie stuff that they want to just make available for people to quickly deploy, they can do that as well. So we are going to come to the products page, and you'll notice digital experience here. One thing you might notice, especially for you guys all know DX, this version number might look very strange. We have a bit of work left to do to expose the product version here instead of what this is. This is actually the Helm chart version. And so every card in this catalog is actually a Helm chart at the end of the day. It's a collection of Kubernetes YAML files that tell Kubernetes how to deploy this application. And a Helm chart, it's basically a tarball with a version and a name. And so this is showing the version of the Helm chart, which is important in some cases, but especially on the products tab, people want to see the product version. So it should be 9.5 or 10.x or whatever it is for DX. So there is work coming to change this. But for now, the latest version of DX is the one you can pick. The way you create a solution, and actually I should say what a solution is. So a solution, a Sophie solution, is a collection of one or more of these things packaged up in its own parent Helm chart so that it provides that single user experience. So I could pick, 10 services here that I'm interested in on the services tab, maybe a database, a testing tool, maybe some other function, and I want to make all that a deployable unit. I can pick and choose some things and package them all together that way. In the case of products, it's usually going to be, one or maybe two products you package together, or maybe you don't even want to. Maybe you just want to create one. So here we're going to create just a solution that only includes DX, and we'll see what that means. So when I click on DX, the UI changes a bit. I get this little check mark up here, and this tab on the right side should open. This is giving me the option to create a new solution. So I give my solution a name, whatever you want to call it. Actually, I'll just call it that. And what this is showing is what you've picked. So for example, if you picked another one, you would see multiple pieces of content here. There's some Sophie common services here, and we'll see what those do in a second. The important one for DX to disable is access control service. This is a service we provide in the solution for services that don't have their own authentication, don't have their own user management. We also have some work coming up where we'll be smarter about this, and we'll know that because you picked DX, this should be disabled. So that's coming soon as well. But for now, disable that service because it'll get in the way of getting to DX. These other two services, though, are useful. Sophie Home in particular, which we'll see, it's a web app that runs inside your cluster and gives you information about how to get at the stuff you've selected, like DX and other things. And there's a monitoring dashboard, which is pretty basic at the moment, but will grow. So once you've done that, you can hit create solution.
Yeah,
and
thank you. Jeff, one
Yep.
question here. Could we also include the API then, the Experience API as a service on top of this?
Yes, there's an issue at the moment. Let me just double check. I think the problem is picking both. There's a conflict. Let me just check one thing quickly here. Release notes. We had a release note that went out about this. For now, let's not do it, and I'll get you the proper answer. I believe the problem is the Experience API chart also includes DX, so there's a conflict when you do that. So you could actually choose Experience API instead of DX. You could try that.
Yeah. Okay. Yeah, but shortly, of course, we all want to be able to select and the Digital Asset Manager, which is coming shortly, the Experience API and DX, so we got the full package available.
Yes, and one thing I didn't mention, and actually if I go to we have an internal version of Sophie where more things are enabled. Let me just go here for a second. Do we do it here? No, it's not here either. We're talking to some other product teams like Domino because they have use cases that are slightly different. So Domino by itself is pretty uninteresting, right? It's a server and you need to install applications, or it's a database and server, install applications on top of it. So they will actually want to surface here a catalog of Domino apps as well. So make it a proper catalog specifically for Domino apps. So we've also talked about this with some other folks, like for example, for DX, maybe there's a bunch of different demo apps, which we'd want to make available here that show off different things in DX, and those could each be their own cards. We might have another category up here for that type of thing. Okay, so if you've created your solution, sometimes there's a refresh issue on the page that we're currently working through. So if you're not seeing your solution that you created get highlighted or show up, just try refreshing the whole My Solutions page and it should show up. Usually takes a minute or so to create the solution. When you click on this solution, you get taken to basically the solution page for what you created. It'll be a summary of what you selected. Importantly though, you'll see some stuff on the right here. So for those of you that don't have access to Google Cloud, but do have access to Sophie here, we do provide a sandbox environment where you can kind of very quickly press play, and this will go deploy your app onto our GCP cluster that we maintain for this. We pay for this obviously, so we're okay with customers doing this. We're not sure we want everyone in HCL using this capability. But if you're stuck and you need to deploy something quickly, you can. In our case, we're actually going to deploy to your live GCP clusters. So what you're going to do here is you're going to download, just click the solution package up here. This is the Helm chart. So you're going to download this locally, and then you're going to go back to your cluster, and you should still have your browser open with the Cloud Shell in it. If not, you just hit connect and go back to the Cloud Shell. And then, as I mentioned earlier, there's this really handy upload capability. So you go over here to the 3-dot menu, the More menu, and you say Upload File, and you upload the thing you just downloaded from Sophie. And this is going to upload it to your current folder, your home folder. So now if you do an LS, you should see the thing you just uploaded. If you did want to take a peek in there, it's interesting. It will have a couple different YAML files. We're going to play with Kubernetes a bit more after this has been installed, but we're going to kick off the install now and then come back to it once it's ready, because DX actually takes about 10 or 12 minutes to get fully stood up currently. So now that we've got this, if we go back to our document, it'll show us how to run that Helm install. Oops, wrong place. General files, GCP setup. Yeah, so in the second to last section, we'll see a couple Helm install commands. So basically it's going to be this example one that we do here, but we're going to override it with our whatever solution name you picked and version. So you basically just copy that and take it over to your Google Cloud environment and Control V it, and then change the name to your solution name. And once you hit that command, you'll see these error messages. That's just a current issue with something that'll go away. But you'll see a whole bunch of text here. And the important part is not this text, it's about the fact that Kubernetes is now dealing with all of the YAML that just got pushed into it, and it's going to do a whole bunch of things. So now, if we do a kube control get pods, you're now going to see a whole bunch of stuff going on. So there's the cert manager stuff that we installed earlier in the setup in our default cluster or default namespace. But now all of these things are in various stages of starting up. So these are all pods. So, best way to think of them, these are containers running. And so we can see some of them are already running really quickly, although not quite ready yet. But it's the difference between ready and running. Some are creating. And if you do this command again, you'll probably see the states have changed. More will be running. You'll see one that has an error. That's the Grafana job. That's expected. This is a one-time job that runs, and until it's able to connect to the thing it needs to, it throws an error, but it'll eventually fix itself. The kube control commands have some really useful capabilities. I can say kube control get pods -W, which means watch. And what this means is I don't get my command prompt back, but if there's a change in any line of the output, it's going to show me that change here. So it's basically, if I want to sit here and wait for stuff to get up and running, I can just do this. And so there we've got the Grafana job went from running and then back to error again. And so, yeah, you can, oh, there's an error in let me just check the error quickly. Oh, yes, so, yeah, just responding to the chat here, 1 second. Yeah, so for the chat there, the part that's missing is Helm requires a release name. So put something like MyDX or whatever you want to call your release before your tarball name. Okay, so things are still happening here. So if people can get to this point, then I wanted to switch over because, as I said, DX takes a bit to get up and running. So I wanted to switch over and start doing some more generic Kubernetes things, then we'll come back to DX and make sure it actually got up and running for folks. So again, really nice thing about the Google Cloud Shell is I can run multiple tabs. So I can create a new tab over here. And because this is on the same environment now, I can do, I don't have to run a connect again. I can do get pods and I'm still connected to my cluster. So I can see what's going on here. Okay, so there's another document that I provided in the Teams chat called the Kubernetes Workshop Kubernetes. It's basically a cheat sheet where we're going to run through a bunch of these commands. The important part is if you can download the 3 YAML files that are in the Teams area. So there's deployment, pod, and service. And I found with the Teams download, if you do more than one, it'll package them up as a zip, which is kind of weird. So I just do them individually. You could do it and then extract it on your Linux machine, but I don't know really why they do it this way. So once you've got the 3 service or the 3 YAML files downloaded, then same thing in your Cloud Shell, just upload those 3 files. And here you can do all 3 at once. So you can just 1, 2, 3, and all 3 will get uploaded to your current folder. So I'll wait for folks to do that for a sec. And so what I wanted to show with these files is to kind of drive home some of those core concepts we talked about earlier and show you what the YAML starts to look like once you start digging into this stuff. Oh, another issue. Let me just check the chat here. Unable to build Kubernetes objects from release manifest. That's interesting. That error in the chat. I'm trying to think what could cause that. Yeah, we may have to follow that one up offline after. Seems like it might be an issue in the chart, but yeah, I'll take a look after we're done. Okay, so yeah, basically I want to start to look at the YAML, and again, we'll go from the ground up here. And so if you take a look at the pod YAML, it is as simple as it can possibly get. So for all of these examples here, we're going to use Tomcat because it's a server that most people have heard of, and it starts pretty quickly. And so if I just wanted to do nothing else but just stand up a container or pod in Kubernetes, this is what I need. This is the most simple YAML. So the way to read these YAML files, there's always a version. So basically these YAML files are telling Kubernetes to do something. And the way they do it is we're interacting essentially with the Kubernetes API. And so here we're interacting, and there's various namespaces in the API, but here we're interacting with version 1, and we're telling Kubernetes we're going to create a new object called a pod. We can give our pod a name, and the important part here is what containers make up this pod. And so here we're giving our container a name. The important part here is this image tag, which is, because there's nothing else specified here, it's going to pull it from docker.io. And we're going to, we know that Tomcat exposes its traffic on port 8080, so we're going to expose that here. So the way you apply this thing is literally with kubectl or kubectl apply -f for file, and then you just give it the file name. And this is going to return immediately. And if I do a kubectl get pods now, we will see there is a Tomcat pod that is now in the process of creating. And what that usually means is it's either being downloaded or it's just starting up. And I can do a lot of the same stuff that we did with Docker earlier with kubectl. So I can say, show me the logs for the Tomcat pod, for example. And there's all the Tomcat logs. So it looks like the server startup's already done, so it is running. I can also do the exact same thing we did before with logging in to a pod. I can do kubectl exec. There's a slightly different syntax when you're running a command inside a pod. So it's kubectl exec -it for interactive, and the pod I want to run it on, and then this weird little thing, and I want to run bash. And so here I'm now inside Tomcat, and I can navigate around as if I'm in the container. But this is really, really unuseful. So if we do a kubectl get pods again, let's take a look at okay, so the pod name is Tomcat pod. If you want to get all the information available about any object in Kubernetes, you use kubectl describe, and then you say what type of object you're interested in knowing about, and you say in this case it's a pod, and it's Tomcat pod. So this is going to return a whole bunch of metadata, basically everything Kubernetes knows about the desired and current state of the object. Important part is usually at the bottom here. There's this event section which will show you the kind of the history of what happened with this pod. So we can see it pulled the image at one point, it successfully pulled it, then it created the container and it started the container. So when you're having issues with pods starting up, this kubectl describe is really helpful. And you can do this for pods or any other objects as well. And you get all this other information up here as well, which we won't go into yet. But for now, let's do this. Let's delete this pod because we're not going to use it anymore, because there's no way to get at this pod from the outside world right now. We are going to create a proper deployment for this pod and a service which will actually do a external IP address for, so we can actually interact with Tomcat in our browser. So to delete a pod, it's basically probably what you would think: delete pod, Tomcat pod. And this one usually thinks for a bit because it makes sure it understands all the resources, and then it will just return when it's happy that it's going to be able to delete it. And this is another interesting thing about Kubernetes. If you're fast enough and you do get pods, you might see, and in this case, they probably closed too quickly, but you'll sometimes see pods in terminating state or closing state as they shut down. But in this case, not so much. Okay, so what we're really going to focus on here is doing a proper deployment of Tomcat and showing how we can scale that deployment even, and then wrapping it in a service that's going to get a publicly exposed IP address so we can actually do stuff with it. So if we take a look at the deployment YAML, it's a little longer, but still quite easy to understand. It's also got a specific version of namespace it lives in. We're telling Kubernetes we're going to create a new kind of object called a new type of object, and the kind is a deployment. We give our deployment a name, and the important part here is down here in the specification view or specification section. We're saying how many copies or how many replicas of the Tomcat pod do we want. We'll start out with one and we'll scale that up. And other stuff in here is a bunch of labels, and then the exact same container specification that we had in the pod. So again, to deploy this, we're going to do exactly the same thing. kubectl apply -f deployment YAML. This should also return immediately. And now when I do a get pods, it's going to look slightly different. I don't have that kind of nice name, Tomcat pod. Now I've got this kind of strange name, Tomcat deployment, with a generated ID at the end. And that's because a deployment is responsible for starting and stopping many pods. So it needs to generate unique names for pods. So one thing we can try right off the bat, just to show the scaling and how easy that is, you can try something like this: kubectl scale, and we're going to scale our deployment. And our deployment, oh, actually, before I do that, deployment is a first-class object in Kubernetes. So in addition to getting pods, I can get deployments. And we'll see our deployment in here. It's actually called Tomcat deployment. So it's got a nice name because there's not multiple copies of the deployment. It's a singleton object that then goes and stands up multiple versions or multiple replicas of pods. So I can scale this deployment by doing this: kubectl scale deployment Tomcat deployment, which is the name. And then the important part is I can say ---- replicas, and then I can pick whatever number I want. Let's say I want 5 pods. Now, if I do get pods again, we'll see rather quickly, in this case, Tomcat starts really fast. If the pods took a bit longer to start, we'd see some in different states here. But you can see now I have 5 pods pretty much immediately ready to go and ready to support whatever fronting service or load balancer we put in front of this capability. So that's, and then again, if I want to scale it down, same thing. You just scale it back to 1. And if I go quick, yeah, there we go. So I can see I scaled it back to 1, and I did my get pods quickly enough that I can see 4 of them are now in terminating state and just left the 1 running. So this is Kubernetes waking up and seeing, oh, there's a new configuration, replica should be 1, and then it goes off and does the work to make that desired state the actual end state. So now if I get pods again, I only have the 1. Okay, so that is basically about getting the pods up and running. But as I said, if you want to actually interact with this capability, we're going to need another level of abstraction. That's a service. So we have the service YAML. If we take a look at it, it's nice and short. Again, these YAMLs are sort of purposely chosen to be short. These get much more complex. And in fact, if you look inside your solution Helm chart that you built, you'll see deployment and service YAMLs that are much more complicated than this. But this should be enough to get the points across. So again, version 1, we're creating a new type of object. It's kind as a service. And in this case, we know that the target ports that the pods that service this, or that are behind the service, are talking on port 80, but we want to expose our traffic, let's say on port 80, to end users. So services can do this mapping. They can say, even though pods might be communicating on some arbitrary port, we want to make it on common ports, 443 or port 80 or whatever it is. So you can do all of that in your service YAML. And to deploy this, not surprisingly, it's kubeapply -f service YAML. And because services are a first-class object in Kubernetes, you can say, get me services. And this is going to list you all of the publicly, or all of the provisioned services. And there's some important points to note here. The one we just deployed is this Tomcat service. As we saw in the charts, it gets its own internal IP address in the cluster. But this, you'll notice, is it says pending for an external IP. And because we made the type, I didn't actually highlight that, but in the service YAML, we said we want the type of this service to be load balancer. And this is a special type of service for some of the cloud providers like GCP or AWS. They will actually go out and provision you a static IP address from their pool and make your service available on that IP address. Now, this is not ideal. This is not secure. By doing this, we are effectively standing up a public IP address where anyone can get at what you just deployed. And we'll talk about the security in a second for how to lock that down. But basically, if I do a get services again, it usually takes about 30 seconds or maybe a minute at most. But GCP will go provision your public IP address for this service. So now, if I take this IP address and I go to my browser and go to HTTP, because we're not doing HTTPS yet, and go to that IP address, it should be, if we're lucky here, should be Tomcat. Maybe things aren't quite running yet. Should be though. Did I grab the right one? Ah, there we go. Yeah, I guess Tomcat maybe has some startup logic the first time it's hit. But yeah, so now we're hitting our deployment of Tomcat on a public IP address that GCP just stood up for us. And this is, if you notice, if you go back to the back to your Cloud Shell, when you did the kubectl get services, you can see that same thing was stood up for our solution that we deployed and is now getting deployed. I just saw a thing post, sorry, I'm not following all the chat. I just saw there's a question on whether there's a UI for normal humans. That's one of the reasons we love GCP. So let me just show you, if I go to my account that we've just been using here, I think I'll need to log in. Oh no, let me see, oh, there we go. Yeah, so in case you didn't know, Kubernetes came from Google. So they are pretty much, from our perspective, the most functional and user-friendly public Kubernetes offering there is. AWS is much more complicated, but all of these cloud providers are starting to put UIs on top of Kubernetes. This is not a Kubernetes function. There is something that used to be called the Kubernetes dashboard, but it got deprecated. But all of the cloud providers will have a flavor of this, where I can, for a given cluster, I can see high-level cluster information. But what I'm really interested in is what's being exposed. So I can come here to my view and I can say, that same way we just did kubectl get services, that's this command here. Or I can filter this easily by showing me, only show me services of type load balancer. And so they provide lots of capabilities like this, where I can quickly get my view filtered down. And when you dig in here, this is where the value of these UIs comes in. So let's say I see my Tomcat service is serviced on here. I want to know what's behind the scenes of this service. So basically going backwards from that chart we looked at earlier. If I click on the service, I get taken to this configuration page, which shows me some usage information, which is useful. But if I want to really understand what's going on, you can say, it'll show me, here's that deployment we deployed, because all this is tied together with labels and selectors, which you can probably see in the YAML files if you look around. Specifically, I'm interested in the pods. And so this knows that right now there's, actually, let's do this. Right now, I see there's one pod serving that this service knows about. If I go back to my thing here and scale my deployment again up to 5, and go back to my UI here and refresh, you should see now there are 5 pods that this service could use to route traffic to. And you can see right now some of the pods are still starting. So Kubernetes knows that there's not quite 5 pods ready yet. So far, 2 of 5 are being started. The question about doing this all in the UI, yes, you can. In fact, you can do a crazy amount of damage to your deployment in here. So for example, if I wanted to scale back down to 1 from where we are now, I can click on my deployment object. I can say edit, and this is going to take me to that full YAML file, the one that you got when you said kubectl describe, and you find the replicas in here, which will be set to 5, which I just set it to. You set it back to 1, you save it, and that's the same thing as doing the kubectl deploy. So now if I go back to my service, I should see only, yeah, so these are failing or starting to get shut down now. If I refresh, it'll probably be back to, well, eventually when they shut down, it'll look better. But I can also get, if I dig in here and go into my running pod, I can see all the information about it as well, including the logs. So if I wanted to see what are the Tomcat logs, I can get in here and do all that stuff, all from the UI. So kind of really helpful. And there's versions of this in AWS, versions of this in OpenShift, and others, and they're all different, but they all aim to do the same thing. Okay, so maybe if we're lucky, let me go back to maybe I've wasted enough time here, and DX will be up and running. So if we do a get pods. Almost, it looks like. So we can see the DX pod, at least in my case, the DX pod is running. Doesn't seem like it's quite ready yet. And so what we can do now is look at the logs and see what's going on. Kubectl logs, in this case, you do have to grab the whole yucky pod name here with the generated stuff on the background and paste it in. And okay, so it looks like WebSphere portal is open for bit. That looks good. So it looks like it should be ready. So let's try to access it and see what happens. So to access it, okay, back to Helm for a second. If you remember when we ran the Helm install of your solution, there was a whole bunch of text that got printed out, and you probably didn't read it and forgot about it. So Helm provides a bunch of commands to let you say, what have you installed, and give me all that information back. So Helm provides a thing called Helm LS. Show me what have I currently installed with Helm into my cluster. And so here, during setup, we installed Cert Manager, and then here's my my Helm install that I did of my own solution. You can see here, here's my chart that was installed, and more importantly, here's the name I chose for my Helm release. So now I can do Helm status my DX, and that's going to get me back all that text that I probably didn't read the first time. When I go to read this now that my service is close to up and running, we're going to fix this all this text up. It's too much. The important point is just this one, the Sophie Home. This is the place to start. So this provides, and we're going to see if this works. If we go to the browser, you paste that in, but we do need the IP address from the service. So we're going to do kubectl get services. And we're going to grab the other load balancer service, the one for my solution here, ends in 217. I'm going to replace the solution IP with that. We will get a certificate warning here, but once you accept that, you should be good. And this Sophie Home, as I said before, it's a web application that runs inside Sophie Solutions and tries to provide a summary view of the important Kubernetes stuff, but most importantly, the access information for how to get at what you included in your solution here. So, okay, it looks like it just turned green, which is nice. So basically, we're still working on this UI. This was slapped together by our development team. It's just now going to go through a proper design review, so it's probably all going to change. But the important part here is this middle part. It'll show a card for every service you picked when you were in Sophie and provide the important links. And so you don't have to know, for example, that the URL to get at the portal endpoint is /WPS/portal. That's been coded into the Helm chart. So we provide those links. And same thing, if it was a REST API and you need to know the starting endpoint, that would all be provided as links here. And if there's other documentation and other things, you get there. But this homepage link, if we're lucky, should take us, again, we'll have a certificate issue. It should take us to a running version of Portal with whatever the default stuff is. You guys know much more about Portal than I. One of the things we have to deal with on the Sophie team is we work with all the HCL products. So I know only a scant little about each product and not much in depth about anything. So one of the things we have to figure out here is what is the actual production workflow for things like commerce and DX, like how do customers actually work with this? For now, we're treating this really as a demo environment, but to have customers actually do productive work with this, that's going to require some further discussion about the workflow. But some other things you can quickly get to in here. Again, we didn't want to have users have to go to the command line to get at logs. So right here from Digital Experience, we'll show you the one pod log that's of interest. So you can quickly get to it instead of having to go through the GCP or UI or through the other command lines. We also provide a summary of all the information. You get to all the logs really easily from these little black, again, this will be redesigned. These little black things, these are the logs for any pod. So I can click on any one and get taken to the logs for that pod. We can see services and other things like volumes, which we didn't really talk about today, but I mentioned that there's persistent volumes have storage classes and storage types, and that's really what the pod cares about. And so in this case, we can see DX requested a storage class type of standard and requested 80 gigabytes, and it's currently bounded into this pod. Yeah, we do have some other stuff. There is a monitoring dashboard, but as I mentioned earlier, it's kind of basic. We need to build this up a bit more. So you could play around with that. Metrics, I don't know if this even works at the moment. Yeah, this is more for querying what's going on inside your cluster. So you can query for things like CPU, historical usage, and other things if you're an advanced user. And then we also provide this button here, which is, for those of you from the IBM days, we used to have in all of our products sort of a support gather function where go and pull all the important logs together into a big zip that you can send to support. We have the same sort of thing. You press get diagnostic data and it'll package up all the important logs and you can send that to support. So yeah, that's the quick and dirty version of it. Yep.
Just one question. Where do you have the documentation on how to get access to this Sophie Home, building this stuff? And because I'm trying to build the same URL, but I get a stream error on that, connection failure if I use my own IP address. So did you document it somewhere?
Yeah, so one thing I didn't talk about was all the documentation in Sophie. So if you go to Sophie, there's a guide section. Lots of stuff in here. In fact, we document all the steps we just went through for the Google trial account. I put a bit more detail in the document because I want to make sure we didn't stumble, but all that stuff about setting up cert managers in here and all that. And then there'll be information in here about once you install, how to get to it. I'm curious, can you paste in the URL you're trying to get to Sophie Home at?
Yep.
Into the chat? Okay, so in this, okay, so the next thing you would do in this case, this is a typical Kubernetes debugging session, is it looks like something is not healthy. So if I were on your system, I would do a kubectl get pods and see if anything is not returning running.
Well, it's just that DX Anchor, it doesn't have minimum availability. And actually, I can I go to screenshot? Probably not. So the DX Anchor has an error, does not have minimum availability. My DXDX 01 update replicas available, so I think that's still starting. Sophie Home does not have minimum availability. The solution controller doesn't have minimum availability.
Okay, so yeah, that's the problem. That Sophie Home doesn't have the availability. So even if DX isn't up and running, we should be able to get to Sophie Home. So that's the one to focus on. So what I would do then is I would grab your Sophie Home pod name and copy it in the clipboard, and then do a kubectl describe pod and the name, and check the events at the bottom. It's possible something failed there.
Okay. So kubectl and then
kubectl describe and then pod and then the actual generated pod name.
Okay. Okay, so there is a fail to pull an image.
Does it say why?
So ACL products, Sophie Docker, JFrog IO, core service, Sophie, Sora. Actually, I can copy and paste this.
Same image on same error on my side.
Sorry.
Oh, so that typically means there's something wrong with the image pull secret. That it's not. Let me see. Pulling image, failed to pull, bad credential. Yeah. So yeah, in the middle of that it says bad credential. So the important part there is go back and the Cloud Shell here remembers all your commands. So if you go up to the one where it's a kubectl create, where you created the secret, make sure that credential is the right one, and to test it, make sure you can log into Artifactory with that credential right now.
Okay. Yeah. So that's the other one, the second one that you share with us.
Yeah.
Yeah. Okay. Yeah. That's it. Yeah. So one of them I changed the password, not the second one. Okay. So.
Yeah. So the good news is that's the only command you have to run, because that secret is sort of a persisted thing, and Kubernetes will look at it. So if you change it, you just need to change that secret. Oh, so you might have to delete the secret first.
It gives me an error. So how do I delete that?
Yep. So basically do this. Let me get my screen back here. Yeah. Okay. So do this. Do kube control. Actually, we know the name of the secret. So it's just kube control delete secret, and then it's Sophie secret, just like that. And then yeah, rerun it again.
Yep, it's created now. So now let me see. So now we should continue, I guess, or should I kick it off again?
Okay, so now you've got that done. Okay, so this is a really interesting use case. So what you do is, okay, so now when you do get pods, try this. Grab the Sophie Home pod name again, and this time do a cube control delete pod and the pod name. What this is going to do, it's going to shut down that container, and immediately Kubernetes is going to say, oh, we need another Sophie Home up and running. It's going to restart that pod, and that'll kick off a new download, and they'll try to use the new credentials you specified. Okay, I'm just reading some other stuff in the chat here. When running the cube, I get connection to local host was refused.
You got that right at the beginning, Jeff. It's and so I had to just watch it because that just slowed me down. So.
Oh, interesting. Okay.
But I wasn't sure how to get around it because I can't.
Huh. Yeah, that's a new one for me.
Yeah. Don't worry about it. I'll try to fix it at some point. But
okay, so I did want to definitely before we sign off, I wanted to talk about security of this because it's important. Anyone who's got any background in security is probably already wondering about these public IP addresses that we've been standing up that are now open to the internet. Google Cloud in particular and GKE, they really favor ease of use over default out-of-the-box security. So you've got to lock down things on your own. So for example, and I have this at the bottom of the GKE document, but there's two things in particular you should be doing if you're going to have this up and running a lot. So if we come back to Google Cloud, I mentioned that there's, in addition to the Kubernetes engine, there's another section of configuration that's important. That's the VPC network. You can find it in the big list, or if you pinned it earlier, you can find it at the top here. There's a section in here called firewall rules. And when you click in here, and this is actually related to the IP whitelisting that I've had to do for all of you. This probably looks like gobbledygook to start, but if you focus in on a few places, you can kind of see what's happening. Basically, these firewall rules, they sit in front of GCP resources like virtual machines or other things, and they allow in certain types of traffic or allow out certain types of traffic. And in this case, they're allowing certain types of traffic from the internet. So when you're doing CIDR ranges, this 0.0.0.0/0 effectively means the whole internet, means anyone. And so by default, when you create your cluster, you get, and they do this because they want to make sure that you can access your cluster from anywhere and not have to worry about this before you even get started. But anyone can try to SSH to your cloud resources. In this case, your VMs that are standing up your nodes for your cluster. And then when you deploy things dynamically, like a service with a load balancer, like we did, it will go dynamically create new rules that allow traffic on the ports that the service exposes to the world as well. So now, right now, anyone in the internet could try to connect to the DX I just deployed and start doing stuff there. So this is not ideal, and we have ways to work around this, but the best thing to do right out of the box is, first thing, you create yourself your own firewall rule so that you're allowed to get into everything else so that you can delete all the other rules. So what I do typically is I do something like this, allow me in. And in this case, it's only ingress that matters. We're not worried too much about egress. In this case, I'm going to say I want access to all instances in my network. This is basically all resources in my GCP account or GCP project. But the only IP address I want to let in is my current one, which I get from that URL I pointed everyone at earlier. And so I'm going to grab that. I'm going to put it in here. I'm going to put a /32 on the end, which means all the bits can't change. So this is the only IP address now that's allowed to access. And I'm going to actually change this to make all ports in case I need to do anything else. And I'm going to create that rule. And it's actually pretty fast to create it. And once that's there, then I can safely delete all of these other ones, that any rule that has 0.0.0 in it should be gone. And the problem is, as I mentioned, Kubernetes, in GKE in this case, will programmatically create rules with open to the internet for load balancer services. So to prevent that, we actually run a script very often to clean up all those rules. I included the script in the document, but it's basically a gcloud command. So that's the most important thing, is to lock down your rules so people can't attack your endpoints, maybe denial of service, or maybe there's bots out there trying to log into things. There's not much from a secret point of view we're trying to hide here. It's just mostly we don't want people touching our stuff when we're demoing, for example. And so that's one piece. The other piece is back on the cluster. Clusters, so when we run a kubectl command, what we're really doing is interacting with the REST API for the whole cluster. So when you click on the cluster you created and you look at its information, you'll see it has a public endpoint, public IP address. And what this means is anyone in the world can try to kubectl to your cluster. They would have to know your credentials and be able to log in, but if they could guess your Google Cloud credentials, they could get in. So they have a nice solution for this, which is very useful, and we use this on all of our clusters. You edit your cluster and you enable something called master authorized networks. And what this is effectively an IP whitelist for who's allowed to do administrative things or even connect with kubectl at all to your cluster. And so when you set this, you can actually set that, if you just set this to enable, only your Google Cloud Shell will be able to connect. So the stuff we've done so far. If you've got your own kubectl command locally, like installed on Windows, and you want to be able to connect to your cluster from that, you just do the same thing we did in the other firewall rule, and you set up this. I could say it's Jeff at home, and you give only the people access who need it, and then you save this thing, and then anyone else who tries to kubectl to your cluster, even if they have your credentials, will not be able to, because this is now set. And so this will take a minute to get going, but when it's actually saved, we'll see my master authorized network list. So those are both covered in the document. So yes, if you're going to maintain a GCP cluster over time, at the bare minimum, you need to do those two things. So yeah, this is done now.
Just one question. It seems like the Docker instance which is pulled is not the recent one. It's the original one from September last year, right?
Sorry, say again?
Well, if I look at the image that actually is pulled, I'll just put it in the chat. It shows it's taking one from last year, the production version we had last year, but we have a couple of newer versions.
Oh,
So
yeah.
Where do we change this to benefit from the latest version?
Yes. So this is part of the ongoing thing we have the product. So onboarding a product into Sophie is not just about creating the container. It's about creating the appropriate Helm chart and specifying all the metadata so we can get the links. So yeah, we worked with Chet Title to get the initial content onboarded here. We don't have a pipeline to get the latest and greatest stuff in here. So that's going to be coming, and that's going to be something that each product team does a little bit differently, and how often they update this catalog is sort of up to them. But yes, we eventually want all products to be pushing here their regular updates.
Okay.
Yes. So yes, to your question, what we have is the old one, or an older one.
Jeff, I've added my IP for the whitelisting. Can you add me on?
Oh, sure. 1 second. Okay, I see a couple more. So Ernst and Stephen.
Yep, thank you.
Yeah, I'll show you our production GCP account because there's nothing secret in here. So we run Sophie itself in GCP as a as a so actually it's kind of meta. It itself is a SOAFI solution. Helm chart built with SOAFI. So all of SOAFI is a SOAFI solution. And yeah, we have lots and lots of clusters and services running. But to add you guys to the firewall rules, I just do this. Same thing we just did actually. I go to VPC network, you go to firewall rules. I have a special rule for you guys. Actually, I got a bookmark to it. Special rule for you guys called allow all DX field training. And so we're going to edit this and add you guys in here. That's one, and the other one was this one. So we are in the process of getting rid of this IP whitelisting. We're putting some other protections in place. So yeah, because this is not scalable for us. We especially as more and more customers use this, and especially with COVID-19, everybody's on the road with different IP addresses. So yeah, it's becoming harder and harder for us to scale. So
yeah, and also if we have a partner or customer that wants to try this out, I guess we need to work with you to make them sharing an IP address, and then work with you to get this workshop running.
Yeah, hopefully by the time you have a customer you want to try with this, we will have had this IP whitelisting stuff gone. Like we're hoping to have that in a week or two gone. And so yeah, the onboarding process would be talk to Bill, and we'll just onboard the client as a user in SOAFI. So they would basically get the same email I sent you guys last night, the 2 sets of credentials.
Okay, so should we wait 1 or 2 weeks before we actively propose these workshops, or can we get started with this now?
I don't know, Bill, you still on? Yeah, I'd say. Oh, was that Bill?
No, sorry, Jeff. It's Stephen. I can access it now, but in terms of the login, do we use our hcl.com ID or is it the PMP ID?
Oh, did I send you an email? Were you on the list of people?
Let me just check.
If so, your credentials would be in that note. If you were an invitee on this meeting, you should have got a note.
Yeah, I was an invitee, but when did you send the email today?
Yeah.
All right, yes, I got it, yeah. All right, I've got it. Thank you.
Yep.
What is SOAFI technically? I mean, how is it programmed itself? Is this a bunch of Java applications? Is this a set of Node.js applications? Can you explain it a little bit?
Yeah, great question. So we are trying to be as cloud native as possible. So it's fully microservice based. In fact, one of the things we're realizing, and this is what happens to a lot of teams building microservices. Let me just go there again. No, wrong window. Is our microservice boundaries are actually too visible in this UI. So we have a microservice called the service catalog. Its job in life is to and everything in here is based on REST API. So we have a REST API called Service Catalog that gives back all of this information. We have another REST API called Solution Catalog, which is about creating and managing solutions. We have another REST API or another microservice for our sandbox, which is about deploying stuff to our test cluster, and so on. So yeah, all of the stuff is built as microservices. We actually let our dev team pick and choose what languages they were going to build in, because that's one of the best practices for microservices is empower your dev teams to pick the language they like. And what we found happened was, after going and reviewing a couple different flavors, we had some Java, some Node.js. The team is basically organically settled on Golang for a few reasons. So Golang, both Kubernetes and Docker are written in Go, for one. More and more integration projects in cloud native space are written in Go, and it has a few characteristics that make it really, really nice for microservice. One is your app or your microservice, the thing you write in Go, compiles down to a single executable that is so easy to containerize. It's amazing. So you basically compile your app, comes down to a one executable. Your Docker file is basically start with some Linux operating system and copy in this executable, and that's your packaging for the app. The other thing is it's quite nice in that it prevents, or it doesn't prevent, but it makes it much harder to reverse engineer what you're doing if you worry about piracy at all. So right now, for some services, like we have some in HCL's software portfolio that are based on Node.js or Java, those are both, Java can be decompiled down to almost what looks like source code, and Node.js, even though you might run through Obfuscator, you can run tools to kind of undo that and kind of see exactly what's going on. So if we've got some sensitive code in there, like license checks or other things, we don't want to make it easy for folks to figure out how that's done. So Go is also nice in that it's compiled right down. You're not going to be able to decompile it to anything but what you get in an assembler view. So yeah, basically microservices with Go seems to be our default.
Great, thanks.
In case a customer would request to provide us this workshop not in combination with GCP, but with OpenShift, would we be able to deliver that? Do we have any experience in that combination?
Yes, we have some painful experience. I don't know if Rob Holt's still on, but so he was with us at PSCU. We actually went there with the intention of doing a OpenShift-based workshop and doing stuff live. That customer had gone through the process of trying to urgently stand up an OpenShift environment locally and failed, or it was too complicated, or they ran out of time. They're actually bringing in a business partner to do it for them. But that's one of the main problems, is getting a test environment that you can deploy real workloads to. And in general, it's not going to be able to be a public cloud like this GCP thing. We've got to be sensitive about some customers, even in demo environments, aren't going to want to put stuff here. So if customer wants to use this to try to stand up Kubernetes and deploy some stuff they already have there, then that was actually a piece of feedback we got at PSCU, is even for that, we don't want to use public cloud. We got to go have a security conversation, an IT conversation with folks we don't want to talk to make that happen. So for them, the reason OpenShift was the target was because it's on-prem. And so in that case, if we could insist or make the user have some flavor of OpenShift installed ahead of time, then yeah, there'd be no reason we couldn't do this workshop on OpenShift. But we don't have the ability right now to stand up a dynamic OpenShift environment that like we do in GCP here.